What is the name of the topic written in the current sharing screen? Can you see my screen? What is written there?
Sir, it's a Euler and Hamilton, but
So are you familiar with the pattern name? Pattern lock of your phone.
oh, button lock.
Pattern lock of your phone.
Yes,
Okay. So this pattern lock is basically developed based on this Euler path or Hamiltonian path. Got my point? So
yes,
what is basically path? You know, the edge is basically the connecting point between the two vertex. Okay. So path means starting from a node, then pass through the edge and go to another node that is called a path. So I understand this question that can we travel along the edge of a graph starting at the vertex and returning it to traversing each edge of the graph exactly once? For example, uh, consider it is a one node, another node. Can you tell me what type of graph it is?
directed graph.
Okay, directed graph or wheel graph, anything. So it is told there you need to start from, consider this point, start from this point, then you need to travel with other nodes and return back to and return to the original node, but you need to travel exactly once. So this type of graph is known as the Euler circuit, or sometimes it's called Euler path, or Euler circuit, and sometimes it is also known as the Hamiltonian circuit. Both of them are same. Euler path, Hamiltonian path, almost same. Some uh, allow the loop, some does not allow the loop. So how? If we see the next slide or next topic, you will understand. For example, it is an area name is Königsberg of Russia. Okay, so it is there is a river and some path, and you can see there are 1, 2, 3, 4, 5, 6, 7 bridges are there with this river. So they developed one thing that you need to travel from this path, but condition is that you can use the bridge only once. It means that you need to start from the same location, travel across all the bridge exactly once without crossing any bridge twice, and return to the starting point. For example, there are 4 points are given, A, B, C, D. You can start any one of the point, then travel all the bridges exactly once and return back to in here. It is called basically the Euler path or Euler circuit. Got my point? You got my point?
Yes, sir.
Okay. How? For example, if I start from D, if I start from D, this, then this, Possible? Again, start from D. This area is been untouched. So this is how you need to travel all of the bridges exactly once. So this type of method is called the Euler path or Euler circuit. So if any kind of graph is supported by the Euler path or Euler circuit, that must have exactly one touch of each of the node. For example, if you start from here, you can touch exactly one of the node and come back to the starting point. That is called a Euler path. See, if you start from D, come like this way, it is a Euler path. So if any graph has called Euler graph or Euler circuit, it means that you have exactly one path of each of these, what can you say, each of these edges or nodes. Okay. So how the question is come from here, for example, which of the directed graph in figure 4 has the Euler circuit? So let us see the figure 4. This one is a figure 4. So you need to find out which have the Euler circuit. That means starting from the same point, touch all the nodes and again come back to the same point. So you need to find out by like this way. So can you tell me which graph H1, H2, H3, which one have the Euler path?
H3.
H1?
H2.
Like if you see, possible? H1 no. Because you start from A and you cannot come back to A.
H2,
H2, check. If you start from F,
H2
already you touches G twice. Not possible.
স্যার দুইবার করা যাবে না
No, exactly once. So let us see the answer. Who has the graph H2 has a Euler circuit. The path is like this: A, G, C, B, G, D, F, A. Let us see A, G, C. So start from A, G, C, then B, G, E. Why G twice? Okay, so understand from this line, The Euler circuit in a graph G is a simple circuit containing every edge of G. That means you need to connect every edges, not the node, every edges. Okay. There is a one correction from my side. That is, in a Euler circuit of a graph G will be a simple circuit which have every edge of that particular graph, and an Euler path is in a graph G is a simple path that containing every edge, not the every node. It will be every edge. There is a mistake from my side, so it should be every edges. Okay. So now what can be, we can check. So if we consider the H1, you can start that A to D, D to C, C to B. And there is also A to B, but you cannot consider it like this way. So this is not the Euler circuit or the Euler path. So consider the point is that you need to start from a point, travel along all the edges, not the node, all the edges, and return back to the same point. That is called the Euler circuit, and all the paths are known as the Euler path. So do you understand the difference of the Euler circuit and Euler path?
Yes, sir.
Euler circuit means you need to start from a point, travel all the path, and again come back to the starting point. That is the Euler circuit, is a kind of a loop. But Euler path is that all the paths are called the Euler path. So for H1 graph, from the H1 graph, we can find that if we start from A, we cannot return back to the A. So it does not have any Euler circuit. Similarly, it does not have any Euler path. Consider the H3. What about the H3? If you start from A, clear?
Then back to A.
How already I need to use this line 2 times.
তো সি থেকে স্টার্ট করলে তো নাকি যাওয়া যায়
C তে কিভাবে আসবে আবার? Condition is that you need to come back to the starting point. I have covered the second condition. That means all the edges are covered. But the issue is that I cannot come back to the starting point. আমি স্টার্টিং পয়েন্টে আসতে পারিনি, যার ফলে এটা আমার অয়লার সার্কিট হইল না। প্রথম কন্ডিশন হচ্ছে আমাকে আগে ইউলার সার্কিট তৈরি করতে হবে, যেই পয়েন্ট থেকে স্টার্ট করব সেখানে ব্যাক করতে হবে, এবং এডিশনালি কন্ডিশন হচ্ছে সবগুলা পাথ মানে সবগুলা এজ আমাকে টাচ করে আসতে হবে, which is called the Euler path. So in the Euler circuit and Euler path, both are the two conditions you need to satisfy. প্রথম কেসে স্টার্টিং পয়েন্ট থেকে শুরু করলাম, শেষ পয়েন্টে আসতে পারলাম না, ফার্স্ট কন্ডিশন ফেল। সেকেন্ড কন্ডিশন, আই ওয়াজ নট এবল টু টাচ অল দ্য পাথ, দুইটাই ফেল। এইটার ক্ষেত্রে একটা কন্ডিশন ফুলফিল করছে যে আই হ্যাভ কাভার্ড অল দ্য পাথেস, বাট আই ডিড নট রিটার্ন ব্যাক টু দ্য সেম স্টার্টিং পয়েন্ট, সেম পার্টে ফেরত আসতে পারলাম না, এটাও হবে না। লেট আস কনসিডার অ্যাবাউট দ্য H2.
Euler circuit.
So starting from point A, considering all the edges and return back to the same point, that is called the Euler circuit. বুঝতে পারছো এটা সবাই? Euler path, Euler circuit.
জি স্যার।
Yes,
Any
sir.
confusion? Now tell me your pattern log. Does it relate with it?
Yes sir.
So this pattern log is basically works on based on the Euler circuit. but that is not directed graph, that is undirected graph. Next one will be the Hamiltonian path. Yes, Hamiltonian path and circuit. So understand the definition. That is a simple path in a graph G that passes through every vertex exactly once is called a Hamiltonian path. Okay, I just make the confusion between these two. So in the Hamiltonian path through every vertex, what does it mean? Every node, yes, you need to touch every node. In the Euler, you need to touch every path. In Hamiltonian, you need to touch every node. This is the difference between the two, okay? And a simple circuit in graph G that passes through every vertex exactly once is called the Hamiltonian circuit. So when a path touches every node, that is called the Hamilton path. And if a graph has a Hamiltonian path, that type of graph is known as Hamiltonian circuit. Do you understand the
Yes.
definition? Okay, let us see an example. So which of the simple graph in figure 10 have Hamiltonian circuit or not? Let us see. There are three graphs are there, G1, G2, G3. Let us see which one has the Hamiltonian path.
স্যার এটাতে তো কোনো ডাইরেকশন দেওয়া নেই।
G1 and G2.
ডাইরেকশন নাই, কিন্তু তোমাকে দেখতে হবে সবগুলো মানে কলম উঠাইতে পারবে না। ছোটবেলায় যে করছিলাম, কলম উঠানো যাবে না, কিন্তু সবগুলো নোট টাচ করতে হবে।
Sir, G1 and G2.
You cannot lift your pen starting from any point. Any point you need to touch all the notes. So it is a Hamiltonian path. Okay.
Yes, sir.
And this is also the, as this graph has a Hamiltonian path, so we can say it is Hamiltonian circuit. Similarly, let us check. So it touches all the node. So it is also the Hamiltonian path, and this graph is called Hamiltonian circuit. Not possible. So G3 is not possible. So G1 has a Hamiltonian. Why? Okay. You need to come back to the starting point again. So from A to B, C, D, E, and A. So the Hamiltonian and Euler has the same common point. The starting and finishing point will be same. In Euler, you need to cover all the path, and in Hamiltonian, you need to cover all the node. This is the difference. So in G2, if we start from A, but we cannot come back to A, or B, we cannot come back to B. That's why G2 is not the Hamiltonian. G2 and G3 is not the Hamiltonian. Only G1 is the Hamiltonian. So do you understand the Hamiltonian circuit path and the Euler circuit and path?
Yes, sir.
Let us see another exercises. I hope your concept will be clear. Okay, this is the gray code I have already discussed with you when we discuss about the cube type of graphs. Can you see this diagram?
Yes, sir.
So there are 5 graphs are given there. Which one has the Euler path or Euler circuit? Try by yourself. Which one have the Euler circuit? Which one does not have any Euler circuit?
Sir, 1, 3, 4, 5 are Euler circuit.
1, 3, 4, 5. So if we start from here, as a Euler, we need to cover all the path, not the nodes. How?
Sir, Hamilton.
No Hamilton. I said about the Euler. Only Euler. When it is Euler, you need to consider all the path, not the node. And when it's Hamilton, you need to consider all the node. So A is not the Euler.
Not Euler.
2 is Euler. Okay, I'm giving you some task like write page 7 to 4 of the book. Exercise this exercise 1 to 8. Then 10. Then this one 18 to 23. 26, 30 to 36, that's all. So these are the two problems related with Hamiltonian and Eulerian path. And I hope in the next topic is the digest the shortest path algorithm. After that, your graph will be finished. Then we will start from the tree. After the graph, next session will be the tree.
Would you please repeat the task number?
Again,
Yes, sir.
okay. Page number most probably 724. Page number 724. 724. This first part, exercise 1 to 8. Exercise 1 to 8. Then number 10. Question number 10. Okay. Question number 10. Okay.
Yes, sir.
Next,
sir.
next question 18 to 23.
Yes, sir.
Next 26.
Then 30 to 36.
And 30 to 36. These are the task homework. Next class you need to submit it. I hope you will understand by doing this exercise about the Euler and Hamilton path. Then our next topic will be the shortest path, how to calculate the shortest path. After that, we will go to the next topic, which is known as the tree. So any confusion about today's lecture? Is there any confusion about the Euler and Hamiltonian path?
Sir,
No confusion.
I have some questions, sir.
Yes, carry on.
In Hamiltonians, we just focus on nodes, right?
Yes, nodes. That
So
means
we need to cover
that
all
means
the nodes.
you need to touch all the nodes. You
All
need
the
to
nodes,
touch
okay.
all the nodes.
Okay. Then the another one.
Not all the path. Not all the path. If some path remain untouched, no issue. But you need to touch all the nodes.
All the nodes. Okay. The another one.
In
Euler.
Euler circuit, you need to touch all the path, not all the nodes.
Okay. All the paths.
All the paths. You need to touch
That's the
all the
difference.
paths and starting to the and finish to the starting point.
Okay.
Clear?
Yes, clear. Understand. Thank you, sir.